right, good morning, everybody. Hopefully, there's some people here. Let's see what we got. Looks like I got about 4 people watching at the moment. So, it's a good start, considering. So, as you know, you have an assignment due. Not due today. Let's double check when it was due. There's so much going on, it's hard to keep straight. But, let's see. In the meantime, check in, say hi, see who's here. I'm going to my Google Classroom to double check the due date. And it was pretty much done, wasn't it? Weren't we? Nothing's due. Hey, because we did the Q&A, right? What's going on, guys? Connor, Kalen, thank you again. For some reason, my chemistry, specifically the class I'm talking about right now, Google Classroom is acting like a problem. Verify that it's me. Yep, it's me. Just give me a second, guys. Starting off a little rocky already this morning. And, yep, just you two guys. So sit tight for a second. I just want to verify I know what I'm talking about before. Yeah, so you're done. Okay, cool. All right, no assignments due, and we are simply just kind of hanging out, and we're talking about organic chem just to kind of give us some meaningful new information. But if there is an assignment for this, I wouldn't expect it to be too much, to be honest with you. So the Q&A thing, unless you guys have any questions you want to start today's class with, then we can do that. But if not, I'm going to jump right into the, what do you call it? The organic stuff. All right. So I will start reviewing what we talked about yesterday. And if you have any questions, cool. If not, just hang tight and see what we got. So here is the whiteboard. We talked about alkanes. Okay. And they're hydrocarbons with single bonds. All right. And we'll get into how we can figure out double bonds and all that. Then I give you the prefixes. And that's based on the number of carbons. Right? It was the meth, eth, prop, bute, all that stuff. I wrote them down here. Okay? And then we did the naming. Right, with the line structures and all that. Now, the proper term for naming is nomenclature. You guys are learning all kinds of words. So we're going to be doing the nomenclature of alkanes, which are hydrocarbons with single bonds based on the prefixes of the number of carbons. It all works together. So here we go. So we did stuff like this. So 1, 2, 3, 4, 5, 6, 7. All right, and let's say I put 2 there. Man. There we go. 2 there. And let's put 3 here. Okay. Now, to name this alkane, it's no longer a straight chain, so we can't just call it heptane or whatever. We first have to find the longest chain. Now, this might be a little tricky at times because of the branching, but we could start here. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9 versus 1, 2, 3, 4, 5, 6, 7, 8. So this will be carbon number 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, some of you might say, well, couldn't this be carbon 1? Yes. It could, but notice that if I go 1, 2, 3, I now have a branch versus 1, 2, 3, 4, I have a branch. So you always start, number 1 carbon is the one closest to the branching. So since it's 9, it's going to be something nonane. Okay? Now we have 2 branches here. This is the first one we've seen with 2 branches. So on the 3rd carbon, we have a methyl, right? So it's a methane. It's 1 carbon, but it's a methyl. Over here we have 1, 2 carbons, so that's an ethyl. So we have 2 methyl and 6 ethyl. All right, now, here's where my memory starts to dwindle a little bit. I don't remember if I'm supposed to put these in order of number or alphabetical order. I think it's number. So let me look that up real quick. So long chain organic nomenclature. I'm sure this is thrilling for you guys. Let's see. They're called the IUPAC rules, International something or other. All right. Identify number of the carbons on the parent chain from the end that gives you the lowest. Okay, the same substitution more than once. The location of if there are 2 or more substituents. Here we go. That's what we would call these substituents, the branches. If there are 2 or more different substituents, they are listed in alphabetical order using the base name. Okay. The only prefix which is used prefixes are used in different determining. Okay, so this would be called 6-ethyl, right, with a hyphen, 2-methyl with a hyphen. So 6-ethyl, 2-methyl nonane. How smart do you sound right now? Look at all this crazy stuff that we just talked about. Now, I'm just making these up, all right? What if we have more than one of the same substituent? So let's do octane. All right, 1, 2, 3, 4, 5, 6, 7, 8. All right, looks like 8 carbons there. Let's say I put a methyl there and a methyl there. What's crazy is I could put a methyl here as well. So I know that the longest chain is 8. 1, 2, 3, 4, 5, 6, 7, 8. Even if I start here, I got 1, 2, 3, 4, 5, 6, 7, 8. So it doesn't matter if this is carbon number 1 or if this is carbon number 1. But I got to make one of these 2 carbon number 1. Because if this was carbon number 1, I'm not getting to a branch until all the way over here. So it's going to be something octane, right? Well, it looks like on carbon number 2, I have a methyl, so 2-methyl. On carbon number 3, I have a methyl, 3-methyl. Here's 4, here's 5. So carbon number 5, I also have a methyl. So it looks like I should be able to group these together. All right. So I have this is crazy. You ready? 2, 3, 5. Trimethyl octane. 2,3,5 trimethyl octane. This is pretty crazy stuff. But this is the basis for understanding what happens in organic chemistry, because if you have to determine the name and the structure, or vice versa, then you can do all kinds of stuff. Now, I'm going to make this up. So let's say I have, oh, man. All right, let's make a hexane. All right. Let's say I got 2. Nope. Yeah, let's do 2 dimethyl hexane. So there's the name. You got to get the structure. So it's a hexane. So 1, 2, 3, 4, 5, 6. Well, on 2N2, which is the same carbon number 2, I have 2 methyls. That's how you would draw that. That's that. I mean, it's not that bad. All right. Now, we also started talking about cyclos. So I could do a cyclo. What do you call it? Propane. Which would be 3 carbons. So 1, 2, 3. It's really just a triangle. You can have a cyclobutane, which is 4. 1, 2, 3, 4. And then you link them together. And then you can have a pentane, which is the hardest one for me to draw. For some reason, I struggle with that. It gets crazier. Cyclohexane is the hexagon. Cyclohexane. Okay. Cycloheptane is probably, as they get bigger and bigger, they get more difficult to draw, to be honest with you. I misspoke when I was talking about pentane being the hardest, cyclopentane. Yeah, when you do the YL, that's when you're talking about a substituent or a branch, not the whole thing. So I wouldn't call this cyclohexyl unless, watch this, 2-cyclo, wow, I can't even spell, 2-cyclohexyl, right? Octane. So 1, 2, 3, 4, 5, 6, 7, 8. On the second one, I have a cyclohexyl, which is different than cyclohexane by itself. Now, if you remember, before I go any further, let's address this. This isn't really drawn to scale. So don't think that these 6 carbons are smaller in size or closer together than these. It's just, this is how it's represented when you draw out these diagrams. So it might appear that some of the substituents are drawn a little smaller than they really are compared to the rest. It just saves space, and it's just a representation of what's going on anyway. Now, I hope that answers your question. So you could do all that no matter what. Let's say I have a decane, and these things can get nuts. You ready? So remember alphabetical order. So let's do 2-cyclobutyl, okay, 3,3-trimethyl, 4, here, let's make this a triethyl to keep it in, nope, that would be di, wouldn't it? Diethyl, trimethyl, and I'm running out of room, decane. Hopefully that fit on camera. Okay. Now, this is a long, crazy name, okay? But you always start at the end. So it's a decane. That means 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Here we go. On the second one, I got to put a cyclobutyl. So just make this carbon number 1. Cyclobutyl. It's 4 carbons. So you really can't draw it like this, right? It's got to be connected at an intersection. So that's why it looks like a diamond. So it's going to be connected to the first carbon, second, third, fourth, and then it's connected back. That's how that works. On 3 and 3, we have 2 ethyls. So 1, 2, 3. So meth, eth, meth, eth. All right? Let's do that again. All right, then on the fourth one, which is right here, we have, really can't do tri, and I forgot a second 4. So let's do di, okay? 1, 2. There you go. So this would be called 2-cyclobutyl, 3,3-diethyl, 4,4-dimethyl decane. Yep. You sound like a genius. It's just the way it is, and that's how this works. So these things can get super, super complicated. Now, there are other things that you can add onto here. So let's say we have an NO2, okay? This is called a nitro group. All right? Now, let's say I have a cyclohexane, okay? Now, I'm going to come back to this nitro in a little bit. We'll build our way up there. So, a cyclohexane would look something like that, okay? Now, excuse me. What this really looks like is you have a carbon in each intersection. All right. Now, each carbon needs 4 bonds total. Each carbon so far only has 2. So, each carbon that we have in this picture should have 2 additional bonds to hydrogens. The hydrogens are going to be used to make up whatever remaining bonds hydrogen or carbon needs. So this starts to get very complicated looking, which is why we simplify the drawing to look something like that. All right? Now, let's say we start throwing in some double bonds. Okay? So let's remove all these hydrogens. Now, let's not get into all the details just yet, but let's say I have a double bond there, right? And let's say I have a double bond here and here. So 2 lines represent a double bond, okay? That means each carbon already has 3, right? So you see how these are kind of like they're at angles and it loops back to itself? If I did a double bond on both sides of a carbon, you can't bend that down for it to eventually loop back around by itself. That's why I skipped every other. So just the physical bending of the bond, you don't really realize this yet because of, we're not there. But I can't fold this. And that's what we need to do in order to get this to loop back around on itself. So that's why you have a double bond here, and you alternate double to single. So double, single, all the way around. Single bonds are able to bend slightly where doubles back-to-back can't. So you can't do back-to-back doubles. Now, if I do have these doubles, that means each carbon has 3 bonds. It needs a 4th. So each carbon gets 1 hydrogen. This is a very common compound represented by a line structure that looks like this. You may see it in the future if you were to pursue something like this. You may see it look like this with a circle. Because basically these double bonds can flip around. And remember I said it's got to be every other. So let's say this double bond comes over here, forcing this one here and this one there. So it just kind of spins around and loops and might go backwards the other direction. This circle represents a series of double bonds, but no more than necessary. So here is, this is the same thing as that. And this is much easier to draw and look at. And once you understand all the intersections and the number of bonds, this gets second nature, okay? Now, this compound is called benzene, okay? You may have heard of something called benzoyl peroxide. Benzoyl peroxide is it's a very common like acne medication, and it's use it for your skin and stuff like that. That's based on benzene. So benzene versus benzoyl, right? Now I wouldn't call this a benzane because there's double bonds. The ene, E-N-E, represents the presence of double bonds. That's why we call it benzene. Anyway, if I were to take a methyl group and put it on any one of these carbons, this now is another very common compound. The name changes from benzene to toluene. Now, this is the common name. I could go through and use those. Remember the IUPAC, the system that I mentioned a few minutes ago where you do the nomenclature? I could go through and say, well, this is a cyclohexane with a couple of double bonds and name it according to the rules that we briefly went over. But everyone just calls it toluene. It's just what it is. So if you have a benzene with a methyl on any of them, you could have it here, right? Because this thing is rotating in space anyway, so it doesn't matter. But the most common way to represent it is to put the methane or methyl up top, okay? So that's toluene. Now, I'm going to redraw a little bigger, okay, so I can use the center of the board. So I got my methyl here, come down, get my benzene, put my alternating double bonds. Remember that nitro group? Okay? The way this works is each carbon should have one additional bond, right? Well, let's put a nitro there, a nitro here, and a nitro there. Don't worry about why I put them there. There's stuff way, way above us because we're actually jumping ahead to like towards the end of the first semester of organic chemistry. Whatever. So, if this is called toluene, right, and I put 3 nitros on there, I'm going to call it trinitro toluene. TNT. This is the formula or structure for TNT, or normally would be called trinitrotoluene. Now, TNT is different than dynamite, which is a common misconception. I don't recall the exact difference, but I'm pretty sure TNT is, I know for a fact this is TNT, but what I was trying to say is I'm pretty sure dynamite is based on glycerin. Dynamite is not the same thing as TNT. Dynamite is indeed an explosive with several components assembled together. But TNT, which would be called another way, is 2,4,6 trinitrotoluene is used as chemicals. Instead, the active explosive dynamite is a chemical called nitroglycerin. Yep. So here's a quick story, and then I will leave you with this. All right? We're going to go away in a moment. So years ago, man, I had to be like 18, 19, 20, somewhere in that age group. I was working for a pharmacy, and this pharmacy, it was CVS. So I was working at CVS Pharmacy, and it's not uncommon for big chain companies like Walgreens, Rite Aid, and so on to actively go out and purchase independent pharmacies and then take on their staff, take on their stock, everything they have in the store, and their customers, their files. So when you're buying as a big company, a smaller company, you take over the entire, everything that they have, all their assets, depending on the deal that you guys signed from one owner to another. So it's called an acquisition, all right? So CVS acquires independent pharmacies, and that's why you really don't see any more, at least in this area, independent pharmacies run by a guy that lives in the community, right? It's what they would call mom and pop store. Well, there's not too many of them left. Independent pharmacies are all but disappearing from at least our area. So anyway, I was involved in an acquisition as an employee. This was, the year 2000, so I was about 19, somewhere in that area. 99, 2000, early 2001, somewhere in there. I don't remember. Anyway, the CVS I was working at acquired a independent pharmacy around the corner, okay? Now, this independent pharmacy, they do not... How can I say this politely? This particular independent pharmacy that CVS acquired was being run by an older gentleman who was ready to retire. And with that, it's speculated that he was not that he was cutting corners, even though I know for a fact he was. Let's just say not every rule was being followed, okay? Well, when we went into the old building to pick up all the drugs in the stock, and we were going to, put it in boxes and crates, label it, and then put it on a big armored truck and have it shipped over to CVS warehouse for them to go through it once and for all and distribute the stock. Now, keep in mind, the medications are the same, okay? But CVS has contracts with certain pharmaceutical companies to buy their stock of that company, of that drug. Once a drug is made and the patent runs out, anybody can make the generic. So the drug may be invented by, like, say, Bayer, but once the patent runs out of X amount of years, any other company can then make it with the generic name. So CVS might have a contract to buy it from company A, but this independent store might have company B, C, D, because whatever's cheaper that month is what an independent company is going to buy. So there was like drugs from all kinds of different companies, and we wanted some consistency. So we just put it in a crate, shipped it off to CVS's main warehouse, and they would figure out what to do with it. That's above my pay grade at that point. But here's the moral of the story. Nitroglycerin is a compound that can be used as a heart medication. All right? And it can also be used as an explosive to make dynamite. Now, nitroglycerin comes in a couple different forms. We would sell it as tablets, and, people would take the medication and keep their heart going. But if you had nitroglycerin liquid, this is what I remember. I could be very, very wrong here. But nitroglycerin liquid is the explosive form. Nitroglycerin liquid or gel or whatever. It was some form. Basically, we went in there, we found a giant jug of nitroglycerin, and we were concerned about its explosive properties. So we had to call in like the police and all that stuff, and it was a whole thing. So this guy had an old crusty crystallized thing of nitroglycerin that was a potential hazard for the neighborhood. And, it is what it is. So that was one story that I had from back in the day. Anyway, tomorrow is Wednesday. No videos tomorrow. So I'm going to say goodbye today, and thanks for just hanging out and listening and letting me go through some of this old stuff. And I will see you guys on Thursday, okay? So no video tomorrow. Thursday we'll be back for a little bit more of this, and we only have so many days left. And, we'll go from there, okay? Cool, guys. Thanks again. I will see you on Thursday. We'll do 8 a.m., all right? We'll just continue with that in the meantime. Cool. Stay out of trouble. Stay healthy. Stay safe. I'll see you Thursday, 8 a.m. right, good morning, everybody. Looks like we're at 9 o'clock, so it's time to get rolling. The schedule for today is Q&A. So if you have any questions regarding the assignment that is due at the end of this week, we're going to use this whole week to do that, to get you through this last unit and make sure you have the best opportunity to get the highest grade possible. There's no sense in, doing other stuff when you got this assignment and the timing of everything. I don't want to make the assignment due today and then have like 4 days of school to figure out what to do. So give you the best opportunity to get the highest grade. It's due at the end of the week. And we will be using this opportunity for all these Q&As. Now, first thing, no video tomorrow. No face-to-face or anything like that. So you will be using tomorrow instead to continue working on that assignment. Now, at this moment, looks like there's 2 people that are here, and I know I'm one of them. Over my shoulder here, I got one. So I'm one person out of 2. My guess is that the other person is either Matt or Powell. Oh, there's Zach. I was wrong. Okay. So I got 3 people. Zach just checked in. So I'm guessing Matt or Powell are the other person. Could be the other people. The other person. Yeah. Okay. Zach, you got any questions? Otherwise, I'm going to, leave you 2 working on that assignment. As of right now, let's double check. As of this morning, no one had turned it in yet. And I know a couple of you guys yesterday said you were working on it. Deeply offended you thought I would be Matt or Powell. Yes. Okay, Zach, hit me with the question. I'll wait for you to type it in. In the meantime, I'll pull up the assignment. As of right now, let's see. Nobody's turned it in, which is fine. It's not due till Friday. I get it. I know some of you guys were talking about working on it yesterday. So it is what it is. So, Zach, I'm just waiting to see what your question is. And, I'll point you in the right direction in terms of anything you need. After today, we won't be talking again until Thursday. So we should get whatever problems you have figured out as best as we can in the meantime, because we're not going to have until Thursday to figure anything else out. So I'll pause. I'll wait a moment for you to type that in, whatever it is you're going to ask. Hi, sweetheart. So you're the other person. It's just me, you, and Zach at the moment. Life of a teacher. What's up, Matt? So we got Matt and Zach. Okay, very good. And it should be one more person, though, based on my numbers. All right, Matt, do you have any questions? I know you said yesterday you were working on this assignment, so you were, already making some headway on it. If you have any questions, now might be a good time to put them in the chat anyway, because, I don't see me doing a video until Thursday morning. Now you guys are just awkwardly watching me drink coffee. No questions. All right, Matt, you're the man. Thank you. Got thumbs up and everything. Very good. So we're just waiting on Zach. All right, sweetheart, what's your question? Let's see what you got. Hopefully, you've gotten the assignment. You are up to, there's 7 questions, totaling 100 points altogether, all based on stoichiometry. Let's see what my beautiful wife's question is. Still waiting on Zach. Sweetheart, I did not eat breakfast yet. Thank you for the concern, but I probably will throw something together. After I'm finished this video, I will let the dog out. Yesterday, I had brunch, so to speak, outside in my backyard with the pup, while she got some time to, be in the backyard before I left for work. This is work. Teaching is work, but the other stuff, that's a work. That's what we call it. This is getting weird. I'm waiting for Zach's question. Zach, are you still there? I'm making burrito bowls for dinner. Sweetheart, go to work. Thank you, sweetheart. I appreciate the effort that you put into my dietary concerns. For those of you who aren't aware, my wife's favorite hobby is preparing food and dinner. And she has the menu planned out for weeks ahead of time. And every day she tells me what she's making for the next several days. I completely forget every time. So, whatever. All right, so Zach, I did not get a question yet, Zach. I did not get 3 messages. This is what I got so far in the chat. Hi, I'm deeply offended you thought I would be Matt or Powell. And then JK, yes, I have a question. So I'm waiting for the question. Just copy and paste it. Send it again. If you already did that, then if you have a question regarding the assignment, I'll do my best. Yeah, go back up in the chat. See if you can copy it. I don't know if you can. Yeah, it looks like, at least on my end, I have the option of copying. And then, so you Control-V, Control-C, Control-V. Copy, paste. This is the first day in a while that Powell hasn't shown up. I don't see her on here. While we're waiting for Zach, okay, I'll go into my laptop and can't copy from my... I'm assuming Ogon means phone. There you go. All right, cool. Yeah, Zach, no problem. In the meantime, I'm going to run something past you guys, all right? So we're just waiting for Zach. No big deal, no rush. We got time, okay? But I don't know if you guys are aware, but I've been doing live streams Sunday night on my own personal channel. Just, because my little channel has, going on 13,000 subscribers. We're closing in on 6 million views. It's a little tiny channel. But started doing these live streams, and I've been messing with transitions going from one camera to another. So I got this camera, and I would have another one set up here. You get the idea. And I have been using that opportunity to answer comments that I've gotten on videos. As of this morning, I built a little graphic. So I have the ability to switch cameras and all that very quickly. Now, don't worry about what it's going to be switching to. What I want you to comment on is the switch. Okay? It's called a transition, going from one camera to the other. And we'll see what it does here. So tell me what you think. Well, that's my my transition. All right. So let's go back to my school stuff here. All right. So I have all kinds of camera stuff going on here, and I get switch back and forth from everything. So that is my transition when I go from one section to the other, and I can do it again at any moment. It goes real fast. And then I could just switch back and forth from anything. So that's what I've been fiddling with, with my stuff. Whatever. It's kind of corny. Zach, I'm running out of things to talk about. I got no idea what to say. Okay, so the question has two compounds, one having 8.75 milligrams, the other one 7.20 milligrams. Is this a question from the thing? From the assignment? Is it number 5? All right, so it said after doing dimensional analysis, left with two numbers like. Is this number 5, Zach? Because I got number 5 up, and I see the 7.20. The original numbers have 3 sig figs, but my results have like 5 zeros. Okay, let's take a look at number 5, all right? So I'm going to go to the whiteboard here, and we can take a look at number 5 on the whiteboard, all right? I'll get you rolling, okay? I won't do the math for you, but I'll at least get you set up, and if you find yourself mistaking your work, then, you know, now's an opportunity to kind of correct it. So number 5 says, how much is left of the excess reactant? Okay, so you got to first identify what the ER is. And it says you got potassium chloride reacting with silver nitrate. So, potassium chloride, silver nitrate. So, potassium chloride plus silver nitrate. Now, you got to do the crisscross with silver and nitrate. It comes out to be a +1 and a -1. So, there you go. All right. Then this is a double. So, you do the switch, potassium nitrate and silver chloride. All right. Everything's a 1, so everything's a +1 or a -1, so everything's balanced, and you don't have to go in there and do anything else. But you do got to recognize that you have 8.25 milligrams of potassium chloride and 7.0 milligrams of silver nitrate. And it says how much is left of the excess reactant. Well, you don't know which one is the excess reactant, so that's the first thing you got to do is figure that out. So you can do some work for potassium chloride and some work for the silver nitrate. Okay, 8.25 milligrams, 7.20 milligrams. And it's 3 sig figs, like you pointed out. I'm going to just go to the same compound for consistency. If I go to one, if I go to the different products, I'm going to get something I can't compare. So for consistency, let's just go to silver chloride. So I got 1,000 milligrams for 1 gram, 1 gram to 1 mole, or certain number of grams to 1 mole. We'll figure out that in a moment. Then it's going to be 1 mole of potassium chloride to 1 mole of silver chloride. Okay? And I'll come back and figure that out. Down here, same setup. 1,000 milligrams, 1 gram, a certain number of grams to moles. And then it's going to be 1 mole of silver nitrate to 1 mole of silver chloride. All right. I think I'm running out of room. All right, so let's get some molar masses here. Potassium. Let's just do KCl. Why am I typing out potassium? All right, let's see. Well, that's why, because it comes up as King's College of London. Potassium chloride has a molar mass of 74.55. Okay. Silver nitrate has a molar mass of 169.87. Okay, so you do the math, and I don't want to like do it for you, but what you would end up getting is 2 different numbers here. Now, I'm assuming based on the math, right? 8.25 divided by 1,000 divided by 74. You get a small number. But isn't 7.20 smaller than 8.25? And you're going to be dividing it by a bigger number. So just qualitatively, not quantitatively, you're going to get your silver nitrate as your limiting reactant. That means your potassium chloride is your excess reactant, and that's what the question's about. However, you still need to punch in the numbers, round it to 3 sig figs, and you're going to get your theoretical yield over here for silver nitrate. All right, I'll let you figure that out. It's going to be 3 sig figs. I'm getting numbers that will like 4 zeros after the decimal, which I like are sig figs. So is there a problem that my results can... All right, here's the deal. Leading zeros, this is the problem that you're having. Leading zeros, something like this, they are not significant. It's whatever comes after those leading zeros that are. So I'm just making up a number. Say I need 3 sig figs. This only has 3 sig figs, this example I just made up. Do not include those leading zeros as significant. They have to be written, but they are not significant. That might change your approach slightly. Hopefully that's all it was. It was just a minor glitch in your sig fig. All right? Yeah, that does change everything. All right? Now, you get your theoretical yield. You know that your potassium chloride is your excess and your other reactant is your limiting. So I'm going to erase all this. You then take your theoretical yield and you convert that, as many steps as you need, to milligrams of KCl. Okay? This will be what is used to make your theoretical yield. You know what you start with. You know what you used after doing this third step. And then you just do start minus used. Do sig figs along the way and you're good. That's how you do that question number 5. So hopefully that fixed you up, Zach. I think you're good now. All right, not too bad. That was just a slight misunderstanding with sig figs, and it should clear you up at this point. All right? Anybody else? Any other questions? All right, very good. So, Zach, you seem to be okay. Matt says he doesn't have any questions. Pal never showed up. And my beautiful wife asked me if I had breakfast. This is a thrilling live stream for the future of America with me educating the youth. Zach, are you good? Any other questions? So give me a yes, no, thumbs up, whatever. Just let me know that you're either good or you have another question, and I'll answer more if you do. All right, cool. All right, Zach, I have a question for you. Let me know what you think of this transition. I don't know if you saw it earlier because you were switching devices, but I do my live streams on Sunday night for my personal channel, and I came up with this transition. Tell me what you think. What do you think? I made that all by myself. That was something I built on the computer. I'm a graphic designer. Yeah, Zach, you will be getting this 100, but you just got to do it. And we'll do more on Thursday if you have another question. So Thursday and Friday will be Q&As. Any questions that you might have? Thank you, guys. I appreciate the feedback. The beard thingy, that's my personal logo for my channel and my business. So that's why I wear this goofy shirt. This is my landscaping shirt, so I go out and cut grass. On the back, there's my phone number with, what I do. And then I use it for my my logo for my YouTube channel as well. Okay, with that, I'm going away. I will see you guys Thursday morning. I'll do 8 and 9. 8 for non-honors, 9 for you guys. And same thing on Friday. All right? All right? Cool. I'll talk to you guys later. Stay safe, stay healthy, stay out of trouble. See you Thursday.